Okay, so when we're transforming linear functions, the parent function y equals x is going to be what everything else stems from. So the slope is 1, the y-intercept is 0, and then, like I said, function notation is where instead of y equals, you have f of x equals, but the rest of it stays the same. And when we go to graph this, which is something we've been practicing all year, we're going to start at the y-intercept, so we're going to start at 0, 0, and if your slope is 1, what is the rise over the run? 1 over 1. So we're going to go up 1 over 1. Up 1 over 1. And then I'll get you guys some rulers so that we can connect that. And then you can connect them with your ruler. Okay, and then this y-intercept was 0, so you do start at 0, 0 for the parent function. Do you guys know the special name that point is? Yeah, the origin. Great, so you start right there at 0, 0. So it goes right through the center of the graph. Okay? This line, y equals x, shows up again in different situations. So in my Algebra 2 class, we were just talking about how when you have functions that are inverses, they reflect over that line. And you'll learn more about reflections next year. But we're going to start a little bit of that today. Okay? So in Desmos, we're going to graph the functions in the table together, and then you're going to say what happened to the function. So for this one, I'm going to graph it for you, and then you're going to tell me what happened. We're going to come up with that together, okay? All right, so you guys did a really nice job of observing what happened with the graph in each one of these units. So it moved down 2, down 1, up 3, up 5. So let's create some rules. So when B is blank, the graph moves blank B units. Okay, so remember B is your intercept. So for the first two, what were the B values? They were both what? Negative. Good. So when B is negative, where does the graph move? Yep. Do you guys think you could fill in the second one without me? And this is the equation that we're looking at. So when the slope is 1, your B value, if it's negative, it's moving down. So what's the other case? If it's not negative, it's going to be positive. And where's it going to go? Up. Oh no, you poor little marker. Okay, so then if it's positive, when B is positive, the graph is going to move up. Okay, so there's a special name for this type of transformation. So we're going to talk about lots of transformations in this unit. This type of transformation is called a, do any of you think you know it? It does start with a T. It's called a translation. It's a translation. Okay, so that's where the graph moves up or down. A translation. Okay, so for this part of it, we're going to graph the functions using Desmos again, and then we're going to see what happens to the line and what happens to the y-intercept. Okay, so we're just going to cut this in half. Okay, and we're going to talk about what happens to the line here and what happens to the, so over here we're going to say what happens to the line. Here we're going to say what happens to the y-intercept, okay? Okay, so when we looked at the line, this line was steeper, so we're going to write more steep, but the y-intercept stayed the same. Okay, so it was the same. It was at 0, 0. Okay, so I'm going to have you get a Chromebook, and then in this column, okay, in this column, you're either going to tell me more or less steep. And again, I want you to compare it to this line. So you're going to have to graph this line first and compare each one. And then for the y-intercept, it's either going to be the same, or if it changes, tell me what that is. Okay? Yep, it's the same, and it's at... Yeah, so remember, if we think of this in the form of y equals mx plus b, what was your b value for all of those? What's your b value? 0. So anytime your b value is 0, what's your y-intercept? It's the same, but what number? Your y-intercept would always be 0, 0. Okay? All right. So for 3x, did you guys get more steep or less steep? More or less? More. 8x? More. This one was actually the steepest of all, the ones that we did. What about 1/2? Less. What about 1/4? Less. Okay, so let's come up with something that explains why these got steeper and why these got less steep. Okay, so here are the steep equations. Those lines are steeper than y equals x. Okay. Yeah, guys, I'm giving you a chance to experiment with some Chromebooks and do some interesting things today, so it's not paper pencil. We're not on other websites. We're on Desmos.com and nothing else. Okay, so based on what you observed, let's create rules for what happens when we have an equation in this form. What value changed in y equals mx plus b? What letter changed? Yeah, your m changed. Good. Okay, so let's create some rules for that. Is there anything you notice about the purple numbers of m versus the blue numbers that I've circled there, clouded in? Yes! I love the way you said that. I was expecting you guys to tell me that that they were fractions, right? Do you notice that those are fractions? They are less than 1, and they are greater than 0, and that's exactly what we're going to say, Jojo. So that was a really great way to word that. So these values, 2, 3, and 8, they are greater than 1. So when it changes to a value that's greater than 1, okay, the line becomes more steep. And the further away from 1 it is, the steeper it gets. That's why the 8x was the steepest. Okay, and then when m changes to a value, it's gonna be less than 1 but greater than 0. So all of these values are between 0 and 1. Okay, the line becomes less steep. And maybe we should put like here, like it, when it's between 0 and 1, it will be a fraction, or it might be a decimal, but it has to be a fraction or a decimal that's between 0 and 1. Okay, and some of you graphed all of your lines on 1, and it makes like a really pretty pattern. So if you graphed them all together, you can actually see that it's turning. The graph turns when it gets steeper or less steep, and that and that type of transformation is called a rotation. So it rotates. It's a rotation. Okay, now in that case, the y-intercept does not change. So a lot of times in math, when there's a rotation, they'll say it's about a certain point. So because the y-intercept doesn't change, it would be about the point 0, 0. Okay, and that's what we would say about the one above, that it would be 0, 0. Okay, and then for other graphs, you might, if you have a different y-intercept, it would be 0b wherever your y-intercept is. Okay. If you can file this in your Okay, so now you're going to graph these functions together using Desmos, and we're going to record what we noticed about the graph. And again, we're going to split this into 2 things, okay? So you're going to tell me here what was the same. Okay, and then for this one, we're going to draw what happened to the graph. So we'll do the first one together. Can you guys see there's 2 lines here that you're graphing? So the first line is y equals x. The second line you're going to graph is y equals negative x. Will you graph those 2, and then we're going to draw a picture of what happens? Okay, so when you're doing a reflection over the y-axis, let's look at our chart. Okay, so the y-intercept stayed the same for all of these sets of lines. Okay, so in our chart for the y-intercept, we're going to write same y-intercept. Okay, this is for a reflection over the y-axis. And then we just said that the slopes are opposite. So opposite slopes. All right, and then I want you to flip to the front. After you get that written down, just flip to the front. Okay, and I think we put it on the second page. Let's go to the second page where we did our chart. Okay, and then on the second page, when we did those graphs, Okay, did the y-intercept change at all? Nope. So if the y-intercept didn't change, that's going to be, for this one here, your rotation, you have the same y-intercept. So I was looking at this chart. Okay, so your same y-intercept and then your slope changed, right? Okay, so the same y-intercept, but we had different slopes. And then the translations are what we did here. Okay, and this is where your slopes were the same. So for every one of these equations, what was your slope? Is there anything in front of the x there? Nope, so your slope is 1. Okay, so you have the same slope. What's going to change? Your value of b. Okay, so in this case, what was your b value? What's your b for y equals x minus 2? Minus 2, yeah. Your b value here would be negative 1, positive 3, positive 5. Okay, so these are your y-intercepts. Are those staying the same or changing? Different. Okay, so the y-intercept is different. Okay, but you have the same slope. That means that if it's a translation, what do we know about the lines? They have the same slope, they're what? Parallel. So if you have a translation, you have parallel lines. Okay? All right, wait for me to put your Chromebooks back, okay?